everyone, welcome back to my channel, The Zoology World. In today's video, I am going to discuss about the amino acids, their properties and types. Amino acids are the compounds which contain carbon, hydrogen, oxygen and nitrogen as they involve the biomolecules. They serve as the monomers or the building blocks of the proteins. They are composed of an amino group, that is the NH3 positive, a carboxyl group COO-, a hydrogen atom and a distinctive side chain represented by R. These all are bounded to one carbon atom known as the alpha carbon. When an amino acid is dissolved in the water, it exists in a solution as the dipole ion or zwitterion. The zwitterion can act either as an acid, proton donor or base as proton acceptor. Hence, an amino acid is an amphoteric molecule. As you can see in this diagram, at the intermediate pH, the amino acid acts as the zwitterion as it consists of positive and negative charge. At low pH, it has positive charge and at high pH, it has negative charge. Standard amino acids. There are 22 amino acids which participate in protein synthesis. Most abundant of them are leucine, serine, lysine and glutamic acid that are found in most of the proteins. The rare amino acids found in the proteins include tryptophan and methionine. Depending upon the polarity of the R group or the side chain of the amino acids, these standard amino acids are classified in different groups. The amino acids consist of three different groups: the non-polar, polar uncharged and polar charged group. Under non-polar group, glycine, alanine, valine, leucine, isoleucine, proline, methionine, phenylalanine and tryptophan key. Under polar uncharged group, serine, threonine, cysteine, asparagine, glutamine and tyrosine K. The polar charged group is further divided into two groups: positively charged amino acids and negatively charged amino acids. Under positively charged, three amino acids come: the lysine, histidine and arginine. Under negatively charged came the aspartate and glutamate. There is one more classification based on the chemical nature of the R group. For example, aliphatic amino acids which have a single or straight chain molecule of the R. They include glycine, alanine, valine and leucine. Aromatic amino acids which have ring structures like phenylalanine, tryptophan, tyrosine. Hydroxyl group containing serine, threonine, carboxylic acid containing aspartic acid, glutamic acid, sulfur containing cysteine and methionine, amino group containing proline, amino group containing lysine and arginine, amide group containing asparagine and glutamine. In this diagram, as you can see, there are different amino acids which contain different R groups. As in alanine, there is methyl group. In arginine, there are three amino groups. Asparagine has amino group with carboxyl group. The aspartic acid has carboxylic group. Cysteine has sulfur. Leucine has a straight chain. Lysine has amino group. Methionine has sulfur. Phenylalanine is a cyclic or aromatic structure. Proline is exceptional amino acid that have a different structure from the basic amino acid structure, which consists of an alpha carbon with four different groups. Glutamic acid, it consists of the carboxylic group. Glutamine has amino group with CO, that is the amino group. Glycine, it has a simple hydrogen attached to it. It is the simplest amino acid. Histidine, it consists of amino group. Then isoleucine. Isoleucine has a straight aliphatic structure. serine has OH group, threonine has OH group, tryptophan is an aromatic amino acid, tyrosine also aromatic amino acid, and valine, it also consists of a straight aliphatic R group. Now the next topic is titration of amino acids. Because amino acids contain ionizable groups, the predominant ionic form of these molecules in solution depends on the pH. Titration of an amino acid illustrates the effect of the pH on the amino acid structure. As you can see here, this is the titration curve in case of the alanine. The titration curve represents the changes in the structure of the amino acid along with the change in the pH. Here, at the pH 7 or approximately near at 7, there is a pi that is equal to 6. This represents the isoelectric point. It is the point at which no net charge and the amino acid is electrically neutral. If you remember, at the starting of the video, we have talked about the zwitterion, that are the conditions when the amino acid has no net charge. So we can say at the isoelectric point, the amino acid exists in its zwitterion form. Isoelectric point is represented by Pi, and its value can be calculated as pK1 plus pK2 by Me2. What are these pK1 and pK2? The K represents the dissociation constant for an acid or a base reaction, and the P represents the logarithm of that Ka. For finding this formula, I am going to show you the simple reaction in which when an acid combines with a base, the products will be formed as conjugate acid and conjugate base. During this reaction, in an aqueous solution, the ionization occurs, and the ionization constant value will be equal to concentration of the products by me concentration of the reactants. In this case, it will be equal to concentration of H plus ion and concentration of A minus ion divided by me concentration of Ha. This Ka value taken as negative logarithm of it will give us the pKa value. So at any point when a reaction is occurring during the titration, when pH is changing, the state of that amino acid will be represented by the pK1. Now take another example. As you can see here, at the 0 point means when there is isoelectric point, there is no net charge and the charge only exists on the alpha carbon carboxyl group and the amino group. When pH is low, at the low pH, as you can see, at low pH acidic conditions prevail, H plus ions prevail. So COO minus of alpha carbon, it accepts one hydrogen and becomes COOH. So net charge will be plus 1. In the case when high pH is there, that means there is capacity to lose more H plus ion. In this case, as already existing charges has no capacity to lose the electron, the side chain consisting the COOH will lose one hydrogen and it will become COO minus. So the net charge will become minus 1. And further, as you can see, if more pH is increasing, then again the NH3 plus will give rise to one more H plus ion, making the net charge minus 2. But during the calculations, we only take pK1 and pK2 value. The value of pKr is not considered. Why? Because we are only considering the zwitterion's change, that is change in the charges of the alpha carbon, not on the side chain. That's why the value of this case will be 3.22, that is taking pK1 and pK2. This is all about the amino acids. Hope you understand the basic concepts, properties and types of amino acid, and also how to do titration with amino acids. If you find this video informative, Do like and please subscribe my channel. Thanks for watching.